In this circuit, we're asked to find the voltage on this capacitor as a function of time after the switch is closed. In this circuit, we're given a 250 milliamp current source in parallel with a 1K resistor. You may recognize that as a Norton circuit, which means there will be a voltage at this particular point. Before we get started, let's review some of the fundamentals from our note cards. First, we have the Thevenin and Norton equivalencies. You'll recall a Thevenin circuit consists of a voltage source in series with a resistor, whereas a Norton circuit consists of a current source in parallel with a resistor. To do the conversion, we can say that the Thevenin voltage is the Norton current multiplied by the Norton resistance. Or if you wanted to go the other way, you could say the Norton current is equal to the Thevenin voltage divided by the Thevenin resistance. And also remember that the Thevenin resistance is equal to the Norton resistance. So when we do this problem in a moment, we are going to convert this circuit, which is a Norton circuit, into a Thevenin circuit. On another note card, you should have some information about RC transients for an initially uncharged capacitor. Here we see that the capacitor charges via this curve right here. We have time and we have the voltage on the capacitor. As time goes to infinity, we see that the capacitor charges to the source voltage. Now, this curve is described by the equation: the voltage on the capacitor as a function of time is equal to the source voltage multiplied by 1 minus e to the negative t over tau, where in this case tau is equal to the time constant of RC. Going back to our original circuit, the first thing we want to do is convert this Norton circuit into the equivalent Thevenin. And we know that voltage, Thevenin, is equal to Norton current multiplied by Norton resistance, which in this case is 250 milliamps multiplied by 1,000. So the Thevenin is equal to 250 volts DC. What we'll do now is we'll replace this part of the circuit with the Thevenin source. Oh, by the way, the Thevenin resistance is equal to the Norton resistance. So we'll put that 1K resistor up here. And we said this was 250 volts. Going back to our note card, we next want to calculate tau, which is the product of R and C. If you look at this circuit, you'll see that there are two resistors in series and then one capacitor. So tau is equal to RC is equal to 1K plus 2K multiplied by the capacitor, so 1 microfarad. If we go to our calculator, we can calculate that as 3,000 multiplied by 1 raised to the negative 6th power. And that is 3 milliseconds. So tau is equal to 3 milliseconds. We can finish by writing down the complete equation. So Vc of t is equal to the source voltage, which in this case is 250 volts, multiplied by 1 minus e to the negative t over 3 milliseconds. And we're done.